Hello, this is Bradley Needham. I'm going to be talking about the strategy pattern and how it can be implemented in C++. So first, let's see what kind of problem it can solve. The strategy pattern allows us to vary an algorithm independently from the client that uses it. We might initially try to solve our problem with inheritance, since we know that one way to vary behavior is through virtual functions. So let's take a look at a simple robot class. I'm going to use struct here to save space so I don't have to type public. I've created my robot here as a abstract class to allow me to inherit the different types of robots from it. So I look at this first and I say, well, you know what? I know that I'm going to have at least two types of robots, and I kind of consider that maybe the search is the most important thing about robot. So the first one I'm going to have is a linear robot, one that searches linearly. Okay, so there's my linear search robot. It doesn't really say much about the attack or the defend because I'm really just kind of concerned with the fact that the type of the robot is linear search. And I say, well, the other important one is maybe a spiral search. Okay, everything's going fine so far. I still now have two more abstract class, linear and spiral, which tell me the base types of my robots. So what is their search? And then I say, well, one of the attack mechanisms is to pinch, let's say. So in order to add that, I need to specify somehow that this happens to be a pinch. So I might go ahead and say, okay, well, I'm going to create a linear pinch robot. And my linear pinch robot then inherits from the linear search and provides a pinch attack. Then I might decide, oh, well, you know what, I need to have a run defend. So now I go ahead and get a run defend here. So I had to put the defend under the pinch because I already had the attack. And in the same sense, I say, well, I need both of those for my spiral as well. So a spiral pinch and a spiral pinch run. So far, this seems okay. But now let's see how I might use it. So I might have a routine go that basically does a search, attack, and a defend on the robot. And when I create my robots, I'm going to decide, well, what type of robot am I going to create? So my concrete classes are I have a linear pinch run and I have a spiral pinch run. And then I can call go on each of those. And if I run this, I get what I expect, linear pinch run and spiral pinch run. But then I go back and decide, well, you know what, there's another attack, which is a punch attack. So I go back over to my robot, and now I have to create another inner line structure here, another type, which happens to be a linear punch. And now I can then also create, so now I also need to create a linear punch run. But notice I'm starting to get a bunch of duplicated code. The defend operation here, the defend algorithm, is not changing. It's still just a run. I have it here in my linear punch run. I have it here in my spiral pinch run. I have it here in my linear pinch run. I have it duplicated over and over again, and the only reason I'm having to do that is because I have to specify, according to an inheritance hierarchy, what the type of robot is. And again, over here, every time I want to use a particular type of robot, I have to make sure I get the right type. So I can change this guy to a linear punch run and run him. And then, of course, I get my linear punch run. So this can quickly get out of hand in the sense that look at how many classes I have had to create and how many duplicate code I have created as well. I've basically done the pinch two times, and I've done the run 1, 2, 3 times. And you can see if I come up with a new search algorithm, that's going to very quickly expand the amount of classes I will need in my inheritance hierarchy. So needless to say, this is going to get way too complicated for what I need to achieve, and I'm going to be duplicating code over and over again. So how might we switch this around and achieve it through, instead of through inheritance, through a strategy? So I'm going to go ahead and clear out these robots. And now I'm going to change the robot to use strategies instead of virtual functions. So let's go ahead and change our robot here so that he's not an abstract class. So now instead of having a bunch of virtual functions in my robot, instead I'm going to create a couple of strategies. I'll have a search strategy, I'll have an attack strategy, and I'll have a defend strategy. So now what do the strategies provide? So the strategies now is a separate inheritance hierarchy, and I've kept them as part of my robot because they still are strategies associated with the robot itself, and their apply method is going to need to take in the robot. In my strategies, I'm going to create a method, apply, which is going to allow the writers of the strategies, the strategy algorithms, to basically provide a callback here, which the robot itself will call in order to implement the strategy, or in order to use the strategy. So let me do that for all the classes, and also supply a virtual destructor for good measure. If your compiler doesn't support the equal default, you can simply provide an empty implementation. And then I need to hold on to a pointer to one of these strategies for each of the algorithms I wish to perform. Alright, so these are my pointers to the strategies I'm going to use, and then my implementation of my functions now will simply apply those strategies. Alright, so now I have each of my strategies being applied according to the function that is being invoked. Let's go back up to the top here, space this out a little bit so we can see it all on one screen. So I've just compacted the code a little bit so that we can maybe see everything here. So we've declared a bunch of strategy structures here, right? We basically have our search, attack, and our defend. We've created pointers to those, right, that they then can be used. Well, where do we get these pointers from? So we want to get them from our user, right, who is then going to specify what type of robot he wants according to the strategies that are going to be used. So in that case, we can use a constructor here, which takes a search, an attack, and a defend. All right, so our constructor will initialize the strategies that we want to use, and each of our functions will then invoke those. So how then do we use this? Well, of course, we need to have actual strategies. Of course, this strategy here, we have to have some sort of concrete strategy because the apply method in each of our strategies is a pure virtual. But instead of having all those duplicate ones, we only need one implementation for a run defend, or one implementation for a punch attack, or one implementation for a linear search. So let's add some of our strategies here. So here's our linear search, which basically inherits from a robot search strategy. Here's our spiral search. Here's a pinch attack. Here's a punch attack. And here's a run defend. Now, how would we use these implementations to create our robot? Let's go back over to the main. So no longer do we have these very verbose types, which kind of made a combinatorial explosion of inheritance types. We just have our robot. Okay, but our robot now needs to be initialized with the strategies that it's going to use. And so we're going to have to create some strategies here. So I've created some strategies. We got the spiral, linear, run, pinch, and punch. And with the robot now, we want to pass in those strategies. So let's have this robot be a spiral, punch, run robot. And then this one can be a linear, pinch, and run robot. Let's go ahead and run that. And in our output down here, sure enough, we got our spiral, punch, run, and our linear, pinch, run. And if I want to change my first robot to also use a pinch, or maybe switch the one to have each one use a pinch or a punch, and I run it again, sure enough, we get the switch spiral, pinch, run, linear, punch, run. Okay, let's look real quickly one more time at the robot, see how our strategy is applied. And you will see this a lot, strategies applied this way where you have an apply method put in. But one of the things we can also do, we could make this a little bit cleaner in C++. And then one of the things I don't like about this right here and the way we've done this is this use of raw pointers, right? Who is actually responsible for the lifetime of the pointer? Of course, in my example, I went ahead and I declared them on the stack here, and then I passed in references to them. But what if they were dynamically allocated? Who's going to control that? Who has to manage that memory? Is it the responsibility of the robot? Does he assume responsibility for the pointer or not? And you have some design decisions to make there. But one of the things we can also do is let's make it a little bit cleaner through the use of operator overloading and functor objects. And I'm going to use a C++ 11 function to make this maybe a little bit cleaner. So instead of having our strategy here with all these applies, let's go ahead and just use a function object from the standard library and simply specify that the search type is basically a callable object that has a overloaded operator paren that returns a void and takes a robot reference as its parameter. And we can do the same thing for our attack and our defend, and they're all going to use the same type. And this could be a different type if we wanted to specify it. Maybe there was other parameters that attack and defend or search take that are different. Now the difference is, again, this is the whole point, was I want to get rid of these pointers, right? Don't want to have pointers here. Then we need to change the implementation as well to, instead of calling apply, we simply invoke these as if they were functions. All right, our robot looks a little bit cleaner now. And what we're getting here is, instead of doing basically runtime polymorphism by having a type, a structure type that I have to inherit from for a virtual function, I'm getting compile time polymorphism in the sense that the search just has to be a type that supports a function. So it could be a pointer to a function, or it can be a functor object, or it can even be a lambda. So let's go ahead and change our types down here. Instead of apply, we're going to just change the apply to operator paren. I can change that for all these. And then these also are not going to inherit from anything. Okay, so as you can see, my new algorithms are basically just functor objects that, basically they overload operator paren to do the operation. And the robot simply calls whatever happened to be passed in here. And the nice part about this, again, I don't have any raw pointers anymore, which I really like. So let's go back over here to my main. I can't pass these things by pointer anymore. And if I run it, I am again getting my same behavior that I had before. But the cool part about it now is that I can actually change this to use a lambda. Let's try running this and see what happens. Let's clear out our output. And now we'll run it. And look at that. We've got our spiral pinch hide robot. All right. Hope that helps.